so done with this class. So stupid.
When are we gonna use this in life? Already in college though.
Good morning, class. Today we'll be talking about derivatives and limits. Lauren, Daniel, why do you have your electronic devices again? I thought I told you guys that you cannot bring these into class.
Bro,
this is a calculus class.
Chill.
Wow, what are you doing with that?
That's like, I don't even know, sexual harassment or something.
You know what? You guys think that you're so good in math that you don't have to learn anything from my class anymore?
You know everything.
Here.
Are you kidding me? We've
Let's
done
put it-
derivatives like 7 times.
That doesn't matter. You still have to pay attention in class. You can't have your stuff out. You know what? If you guys think you're so good in math, let's put it to the test. Class dismissed.
What do you want?
Well,
Go.
have fun.
Oh my, no.
Give it a lose, sucker!
Oh my god. Oh my god. I'm a hedgehog? A stuffed hedgehog? What am I gonna do?
You have just been turned into a stuffed hedgehog. To get back, you must solve 3 math problems.
Oh god. I know. I'll call Daniel.
Oh. Whoa, wait. Why is my phone so big? Oh my god. Am I a domo? Oh my god. Where am I? Huh? Lauren?
Oh my god, Daniel. I don't know what happened. I think the calculus teacher turned us into stuffed animals. The only way we can ever make it back as humans is if we solve 3 calculus problems.
Are you serious?
I'm
I have
so
to do that right
serious.
now. Oh my god.
I know, and I'm a hedgehog. Who even likes hedgehogs?
At least you're not a piece of poo.
Okay, so I heard your phone. Where are you?
Let me see. Looks like the high school. Oh wait, I see you.
Yay! Oh my god, okay, so just come walk over here.
Wait, Lauren, I'm stuck. I can't move.
Are you kidding me? Okay, I'll come walk over then. I can't move either!
Silly students, you can't move yet. First, you must solve this problem. You guys are 100 inches apart. Daniel can move at 45 inches a minute, and Lauren can move at 30 inches a minute. How long will it take you guys to meet up?
Alright, time to think back. If we think of ourselves on a plane, that means that this is 100 inches, and I'm over here. You're over here. And so the equation would just be me minus you, the distance.
Alright,
so
I remember that now.
distance equals L minus D in this case. And
Right.
derive, right? That's related rates, driving.
Yeah, dx over like dy, right?
dx over dt actually, because we're doing it in terms of time.
Oh, okay.
Yeah, so everything is in terms of t. So we know our rates, so then it turns into this. Now, we actually have to integrate that now to find x.
Right.
Once we do that, now we have to find c, right?
Mm-hmm.
So, can anybody tell me how to solve for c? That's right, we know what x is. X is the distance between us. So, 100 equals negative 75 times the time, and that's 0, plus c. So,
Right.
c just equals 100.
No, that's simple.
Now that we know c, this becomes really simple. X equals negative 75t plus 100 that we just solved for. Now we set x equal to 0 because that's when we would meet, when the distance between us is nothing, right? So that, it's basically just writing this again. And using my smartphone, I can calculate this to be 1.33 minutes.
Congratulations, and not bad, but this is just one of three.
Daniel!
Lauren! Okay, well, yeah, that problem wasn't too bad, right?
No, I didn't think so.
Oh, I hope everything else is like that, man. I just want to go back to my body. This is getting annoying.
I know, we're so plushy and squishy.
It took us like 1:33 seconds to walk over here. Oh, my gosh.
Jeez. We should probably start walking back to the high school now, I guess.
Hey, you two,
Okay.
can you come help me?
What's up? What's the problem?
My wife took my son to school, but he forgot his lunch pail. Will you help me bring it to him?
Sure, what do you need us to do?
Totoro's wife and his son are going to school at 2 inches a second and have just turned right at the intersection. If you guys are walking at 3 inches a second, at what rate is the distance between you guys changing? If you solve this problem, you will be able to give the pail back.
Right. So what do you think I should do first?
We should probably draw the diagram.
Oh, yeah, you're right, because it's kind of hard to think about all in your head.
Mm-hmm.
So we're going south, and
And-
they've already gone right,
Right, yeah.
and the distance between us is
The hypotenuse.
exactly, and that's what we're looking for.
Mm-hmm.
Mr. Totoro here said that this is 8 feet. It's a long distance.
No,
And this here is 6 feet.
it's a long way for us.
I know, right? Well, hopefully they aren't there yet. Let's label our points. And we'll call this X, we'll call this Y, and call this Z. Pretty typical. Let's also state our givens so we know what we don't need to solve for. So our givens here,
Would be the rates of Miss Totoro and us walking, right?
well, yeah, so Miss Totoro, how fast is she going again?
I think it was 2 inches, right?
Yeah, 2 inches, right. 2 inches a second.
And we were 3.
Yeah,
Inches.
we're a little faster. So hopefully that'll give us a good edge here. And we know that X is huge.
What was that?
6 feet.
Oh my gosh, that's gonna take us forever.
And Y is 8 feet.
Oh boy.
All right, and we're solving for Z, or to be more proper, dz over dt. So the rate at which the things between us, the distance between us is changing.
Alright, so if you need to solve for dz dt, we need to first convert all the units to be the same, right?
Yeah, and even though we're small, I'm thinking feet will probably be better. So let's do that. We have to change dx dt, right? Because that's in
Yeah.
inches. And dy dt as well. So we know that 2 inches is what we're doing, is equivalent to 1/6 of a foot. And 3 inches is equivalent to 1/4 of a foot. From there, we understand now that dx over dt is the same thing as 1/6, and dy over dt is the same as 1/4. Easy.
So now, then we should differentiate, right?
Exactly. So we know because it's a triangle, x squared plus y squared equals z squared.
Oh, the Pythagorean theorem.
Exactly. And derive that. Can you tell me what that is? I can't remember.
2x
Yeah.
plus 2y equals 2z.
Yeah. Although, because it is related rates, we have to add this implicitly. So we add dx over dt here,
Oh, right, I remember now.
dy over dt here,
Uh-huh.
and dz over dt over here.
That makes sense. Well, I'm pretty sure we know everything now, but we should isolate dz dt to make it easier for us.
Yeah, it'll be so much easier when we put all the information in. So let's bring the 2z underneath. And the 2's all cancel out when you divide. So I'm just going to get rid of that and make it this.
Oh wait, but we still need to solve for z.
Oh,
It's not
yeah.
as easy as I thought.
Well, it is actually. Pythagorean theorem. Back to the beginning. I mean, z is just the hypotenuse of a right triangle, right? And we do know all the other information.
Oh, so let's now plug in chart.
Awesome. Now that we found z, we know everything. Ready? Finally to solve this problem? Here you go. Yay, we're done.
Wait, but why was this value negative 1/4 here? I don't get it.
Well, even though we are moving forward, you have to remember on our diagram, we're going down. And going down means negative, whereas Miss Totoro and the sun are going to the right, which is positive.
Oh, alright. I always got those wrong on the test.
One more.
Wait. Totoro, we have your lunch pail for you. Here you go.
Thank you so much for bringing the lunch pail to us. You've helped us so much. In return, I'll call my husband Totoro to help you up the stairs.
Come to bring you up the stairs.
Wait, why couldn't you have just... Shh. Never mind.
Thank you.
Thank you.
What was that?
I don't know. Wait, I think it's coming from over there. I see a ladder.
Oh my goodness, it's a llama.
Oh my god, the ladder is falling. Go, stop it.
No!
A 15-inch ladder is resting against the wall with a drama llama at the top. The bottom was initially 10 inches away from the wall, but has started to fall down. Luckily, you have stopped the ladder from falling any further. If you push the ladder at a rate of 1/4 inch a second, how fast is the top of the ladder moving up the wall? 12 seconds after you start pushing. Solve this.
Oh no, a ladder problem? I can't do this.
I got this. Okay. It's not too bad, really. It's just another triangle problem.
Really?
Yeah. Here, let's start with the given. So we know that the ladder is 15 inches long, right?
Yeah.
And let's just state x as the length away from the wall, because
Okay, that makes sense.
that's 10. And because we have to push the ladder back towards the wall, we can say that dx dt is negative 1/4.
Oh, because it's going to the left.
And they gave us 12 seconds to solve it. Okay, so now let's put this all into perspective. Here, let me draw a diagram.
Those help.
Yeah. So we know that the ladder is 15 inches and that the ladder is 10 inches away from the wall, right? And because we have to push the ladder back, we know that dx dt is negative 1/4 because we're pushing it back, right?
To the left, yeah.
And because we were finding how fast we need to push the ladder up,
So that the drama llama doesn't get too scared.
we can state that as dy dt. So with that, because it's a triangle, we can just use Pythagoras again. And we know the hypotenuse is 15, so we just plug that in there. And we get that x squared plus y squared equals 225.
Okay, that's easy.
So now with this, we just have to differentiate, right?
Oh yeah, always differentiate.
Alright, so it was 2x, and we can't forget this, dx dt,
You learn
plus
so fast.
2i, dy dt. And when you differentiate a constant, it just becomes 0. So here's where it gets a bit tricky. We need to find the distance. So the equation for that was d equals RT, right? And we already know what our rate and time is, so we can just plug that in. This was negative 1/4, and our time was 12. And this is pretty simple, it's negative 3.
Yeah.
So now, after finding this, we need to find our x and y values to plug it back into our equation, right?
Yeah.
All right, so we know that x here, 10 being the distance the ladder is away from the wall, 1/4 being our rate, and 12 as the time. And this, using my calculator, is easy, it's 7. And y, you have to solve using the original equation, and 7 is x and y squared. So now, do some more math here. Let me find y. Okay, now here for the final step. We just put everything back into our derived equation, which was
Smartphone time.
Good job. That was your final question.
Yay, you saved me! Oh! Thank you so much!
No problem at all. That was fine.
For your great deed, I will give you guys a ride to the classroom.
are you sure? You're kind of small. How are you going to give us a ride?
It's okay. I'm super strong. Oh, here you go.
Oh, thanks.
Wow, I just did not expect that from you. Anyway, thanks.
What?
Oh, finally, man. We're finally human again.
What a
That was
crazy
so annoying.
teacher.
We will never forget our related rates again.
Yes. It's gonna be voiceover like, I have turned you into a hedgehog. The only way to get back is to...
Okay, we're rolling. We're rolling.
It's good.
At last, the happened. Laura, why do you put your phone out in calculus class?
Oh no! Oh, that was so easy. Action.
Oh god.
Oh!
The ladder's falling.
Drop mama! Human again! I know.
Come on, hey! I have fun.
Crazy teacher. We will never forget.
Action.
What?
Yes!
Did you say